Hey there. So, as I was contemplating making my life easier when it comes to development on this platform, it occurred to me that it would be really handy if I could write the software and test it, prototype it, before I actually put it on the Z80 that's in my shed. We're currently in my kitchen. And so I went and I pulled down a Z80 emulator and a DOS assembler so that I was all on the same platform, and I ended up having to modify my program code to work with the emulator because the emulator's UART is much simpler than an actual UART, so it requires less programming, but this allows me to more rapidly test. So I thought I'd show you what I've got here. First we have my program, and the modifications required was to take out the more complicated setup. The UART is set to 9600 BPS 8N1 already, so I don't need to do any of the programming, and it also doesn't have any GPIO, so I've removed my GPIO toggling. The UART is presented as two registers. There is, two I/O addresses. There's a data port, which is either the byte going out or the byte coming back in when you're receiving. And then there's a status port, which allows you to poll that to tell you if the byte has cleared or if there is received input waiting for you. So I have to set up my I/O so that I'm working with what the emulator is doing, and then it's as simple as assembling it. And I'm using the TASM, which is a table assembler, and it'll do a number of architectures, but I'm obviously using the Z80. And then I have, whoops, wrong one. Oh, for goodness sakes. There we go. I have the Z80 emulator by Wiley J. Moore. And this one, I've gone through a couple of the emulators, and this one I like the best because it is very full-featured. It will also emulate, as well as UARTs, CRTs, it'll do disks, it'll do all sorts of I/O devices and things like that. And it's complete enough that you can run CPM or even the multi-user NPM version. In my case, all I need is the TTY, which is the UART, and it's real handy to have this memory display so I can see what's going on. Then we have our current state of affairs up here with what all of the registers are set to, what the processor flags are set to, program counter, and it also does a disassembly when you're stepping it so you can see what it's actually doing. So if I load my assembled code in here, we're going to load it at address 0, and it'll load that code, and we'll move it to single step and we'll reset it and we'll start running. And you see here the first instruction, which is loading SP FF00, load C. Where are we? SP. So I must have skipped past the first one anyway. SP FF00, so this is me initializing the stack pointer. And we can step through it, and you can see it's, we'll take off single stepping, run. So, which doesn't seem that exciting, I have to admit, but it allows me to test out my code and determine if the issues that I'm having with the Z80 platform are programmatic or if they might be hardware related. And in this case, because I was having my issues with it printing the letter R over and over and over again, or the spaces over and over and over again, I've proven that my code does in fact work. So the problem is undoubtedly with the hardware, unless for some crazy reason my code is broken and the emulator and the assembler are broken in the exact same way, which, let's be honest, is kind of unlikely. probably means that, again, I'm having stack pointer issues. I'm not able to write to RAM like I think I should be able to. So it probably means that my static RAM's not latched in correctly at all. So I'm going to have to diagnose that. But yet another tool to help us in our quest to get a working Z80. So again, we have Z80 Emulator by Wiley J. Moore, which is completely free software. Thank you, Mr. Moore. I appreciate this greatly. And I'm using TASM, and I'm not actually sure if this is free or not. I think it is. I found it on Z80.info. So if you guys are looking to do the same sort of thing, this is a real easy way to get into some Z80 assembly programming and do some prototyping without actually having to work with bare metal. Anyways, just a short video, but give you an idea of what I'm up to. I haven't quit yet, and if you want to give this stuff a try, goodness knows, it's real easy. The assembler was something like 400k in size on the download, and then the emulator I think was maybe 3 meg, maybe. So, real easy. And it'll also work with relatively old versions of Windows as well as the relatively new ones, so you could run it on quite old hardware. Anyways, if you've been watching, thank you very much. I hope you guys have a good day.